Okay, now that we've covered some of the broader market dynamics, let's shift the focus a little bit towards specific solutions and investments, especially from Siemens, and how these are helping battery manufacturers scale smart, not just fast. Let's start with Siemens' role in the battery ecosystem. What investment is Siemens making for the battery market's success?
So Siemens, in my perspective, is investing a lot in shop floor tools that enable unparalleled traceability of data. And that's very important in battery manufacturing. And these investments really enable new views, new ways to slice and dice that data to help battery manufacturers make better decisions to be more competitive in a global market, which is an advantage that they need since the US market doesn't have the head start that China has. So Siemens technology platform is really critical in staying globally competitively and being able to ramp up those new production facilities. Katerina, you can speak to those investments.
Yeah, to David's point, yes, we invest a lot in data traceability, but that's just a small slice of a pie of our investment. And maybe you know also Siemens reinvests a lot of its revenue in R&D programs. So we're constantly expanding and advancing our portfolio of solutions. For software specifically, we have a portfolio called Siemens Accelerator. And that really for battery industry encompasses anything from modeling of molecules, like for example, looking for new solid-state electrolyte, to tools that help with the battery design. It's called Battery Design Studio, to MES systems that are specifically developed for battery industry, which makes us unique. Also, aside from Siemens software portfolio, we have other branches of Siemens, like Siemens Factory Automation. They invest a lot in the hardware, and those hardware tools, PLCs and motion controls tools, they help really get those machines, help to connect machines to the MES. So you have this really neat and tight connection between shop floor and between IT and OT.
Yeah, so it seems like obviously battery is a huge focus for Siemens and putting a lot of investment in their time and energy and money into that market. You're living it every single day.
Yeah, so software, hardware, and I didn't even mention our smart infrastructure or mobility branches of Siemens. As you know, Siemens builds electric trains, and we use lithium-ion batteries actually in our trains, and we constantly develop that technology. We have R&D center in Germany that looks into that. And smart infrastructure teams has a lot of solutions that are really critical for integration of batteries with the grid. Or when you build a gigafactory, we have smart building management systems. Cybersecurity is another top topic nowadays, especially with cyber attacks from China, for example. There have been some cases in the news that BMS, battery management systems imported from China, had some malware in them that could really hurt your grid. So we invested in cybersecurity. And aside from that, Siemens, of course, is a big name, and we work with big enterprises, but we also work with small companies and startups. And we have battery startup program that really brings our solutions to companies and helps them to get started early on a digital journey. We help them to reduce costs by helping them to do a lot of prototyping in a virtual world instead of having those startups heavily invest in physical prototyping and burning their money very fast. So, and on the top of all this, Siemens is very active in a lot of in many organizations. We work closely, for example, with DOE and different universities. We help them to develop curriculum to train the workforce for battery industry. We also a member of NADBAT, and as you know, I'm also vice president of NADBAT International. It's North American Association for Advanced Battery Technologies. we are active there, and we help to, force partnerships between different companies.
So it sounds like Siemens wants to be more than just a technology provider, the one that sells the software. They want to help shape the industry, get in on the ground floor of helping develop the battery manufacturing industry here in the US, and help partner up with all these manufacturers instead of just being a technology provider.
Yeah, we definitely see battery industry as a critical industry that will grow over the next years tremendously. And I think it's all about collaboration. If we want to succeed, we need to realize we need to help smaller companies to get off the ground and in the future become partners when they are successful. That's our goal, to help with our tools to scale up your technology faster.
To lift everybody
To
up.
lift everybody up, yeah. And I mean, yeah, it's a very difficult market situation nowadays. So and we see that if you really forge with partnerships with large industrial players who have a lot of expertise in
And a lot of capital.
and a lot of capital and tools and people, people who have seen it, have done it. We hired, a lot of team members who come from companies that are successful in the battery manufacturing field.
I'll say on the technology, what I'm seeing as impacts of these investments is that digital thread. It's more integrated, more flowing of data. You don't have to figure it out as a manufacturer. You go with a portfolio, and you're going to get those integration points to the shop floor, to the ERP, to the PLM. And when that's integrated, again, you have data at your hands. The managers on the shop floor can react quickly. And that game of telephone and email starts to dissipate on the shop floor, which is one of the key things that we try to do, is eliminate that from the shop floor. We want the platform to be successful. We listen to the manufacturing user base and say, how can we leverage technology that Siemens is investing all this R&D time to make better and better for you, to make your lives easier?
So whether it's software, partnerships, talent development, or R&D, we are investing across the board to support the entire battery value chain. Because for this industry to succeed, it needs more than tools. It needs long-term partner. And that's the role Siemens and Index are showing up to play.
It's a very exciting place to be, that's for sure.
Yes, it is.
Okay, so that paints a much clearer picture of Siemens' commitment, which is amazing. But what actually makes Siemens technology unique in supporting battery manufacturing, battery production, execution on the shop floor? What makes it unique?
What really sets Siemens apart in the battery space is that we are not just offering a bunch of disconnected tools. We are providing a fully connected digital ecosystem that's purpose built for battery manufacturing. And it's not just about having a wide range of capabilities. It's the way everything fits together that really makes a difference. We support the entire battery journey, from early stage cell and pack design to factory planning, production, quality management, you name it. Whether you are designing the next generation of EV cells or scaling up gigafactory, we help to bring it all together in one cohesive digital environment. One of the big things that makes Siemens different is how seamlessly these tools work together. Instead of jumping between different systems, everything is connected, from engineering and planning to execution and quality. So when something changes, say a tweak in your battery cell design, that update flows across your entire value chain automatically. Isn't that amazing? And that level of integration helps teams move faster, catch issues early, and stay in sync, even as the complexity grows. And beyond just software, Siemens brings deep expertise in automation, machine control, and industrial age technologies. We understand what's happening on the shop floor and how it connects to the bigger picture. That ability to bridge the physical and digital worlds is something a lot of tech providers just can't match. On top of that, Siemens is not new to this space. You know, we have been around for over 175 years, and we are a trusted partner to major battery manufacturing. In Asian market, we work with a lot of Chinese, Korean, Japanese manufacturers. We are now bringing that expertise in the United States, and we help companies to stand up new plants, pilot lines, and workforce training programs. So when we say Siemens is unique, it's not just because of the technology, it's because we are connecting not only data, but also people and machines into a single reliable system and backing it up with a global expertise and long-term commitment.
So it's the full ecosystem, the full digital thread, all connected, all instead of these individual point solutions,
Yes.
silos.
Yeah.
You have basically the full offering.
And also ecosystem of partners
Yeah.
plays a
Yeah.
major role, and partnership with Index, I think together we can really help the American battery industry to scale up and commercialize their technologies faster.
What do you think, David, sets apart the Siemens solution from other offerings on the market?
One key characteristic that Siemens has that's unique is the drive for innovation, the drive for precision, the drive for quality comes from its roots. And the Siemens ecosystem of technology is driven by that. Now, not only the technology, but then there's also the people side of it. And I think that's a really important fact. There is an ecosystem of people with expertise that can support those manufacturing sites on each of those niche needs, because a design group will have a different need than a manufacturing group, than a quality group. And the ecosystem's there to support all those groups with the same technology that's already connected. So it's a really valuable standpoint when you can invest in a platform and know that platform can touch every point of your organization and still be connected.
Mm-hmm. Yeah, I know from experience, working on projects to deliver and deploy Siemens technology, they're not just a software vendor. They're a partner. They understand the industry that these clients are working in. They understand the challenges. And so it's much more cohesive than just a company selling software. They really partner up with you and make sure that you're successful in all areas of the business that they can help improve.
Yeah, we not just talk about it, we actually do it ourselves. We have a lot of plants that are built using our own technologies. Like one of the examples, during the pandemic, we stood up a new plant in China. And during pandemic, it was really difficult to connect different teams, but having digital tools from our toolbox helped to build this plant in a really short amount of time during the pandemic. So when we say we know the manufacturing, that we can back it up with examples from our own.
Okay, so one major theme keeps coming up. We've talked about a couple times here, but relocation, again, especially from Asia Pacific over to here in the US. Let's talk a little bit about specifically the digital twin technology and how that fits into that challenge. How does Siemens' approach to digital twins specifically help tackle supply chain and production relocation challenges that are faced by US battery manufacturers?
Yeah, good question. So Siemens digital twin technology helps US battery manufacturers adapt quickly and confidently by creating a fully connected virtual replica of their production line or plant. When you are relocating line from Asia, you can use tools like Technomatics or PlantSim to model and optimize the new US factory layout before touching physical equipment. CIMET and NX tools let you virtually commission machines, saving tons of time during startup. And because everything is tied together through our accelerator platform, any design or supply chain change automatically updates your manufacturing and execution plans. That means fewer delays, better flexibility, and smooth transition. So really, Siemens' digital twin approach reduces risk, speeds up relocation, and gives manufacturers full control across design, production, and supply chain, all from day one.
David, I know you can definitely talk about this subject. We're seeing a ton of interest from our clients in battery for virtual commissioning, proving it out in advance. Can you talk a little bit about that?
Yeah, so virtual commissioning is a very powerful tool. Now, battery manufacturers today, they're building their first line. But again, at the beginning of this, we talked about how we have to get to 1,000 gigawatts annually. To do that, that first line isn't going to be enough. So companies realize this, they're building their first lines, but they got 8 or 10 or 20 lines still planned and coming up. So with the digital twin, you can simulate not only your first line, but you have to think about the expansion, your second, your third. It's very common that when you start building these additional lines, they start become generational. The first line was Gen 1, the second line is Gen 2, and so on, because the technology got better, the hardware got better, and you can build better batteries faster at a faster rate than ever before. So the simulation tools, if you take that simulation and then use it, oh, look, I can make my Gen 2 and my Gen 3. Here are the optimizations I've made. Now I can use that digital tool to not only validate that, but then when I go into the commissioning step, I have a complete line that I can simulate all the data that it's going to come with and then validate it with my enterprise systems, my MES, my ERP, and then, okay, I verified that before I even put one piece of equipment on the floor, which is very important because growth at this speed, you need to do everything you can to reduce costs. And digital commissioning with virtual commissioning tool sets, plant simulations, and such are very critical in making that happen.
Do you think virtual commissioning and digital twin technology is important just when you're building that first line, that first plant? Or do you think it's a tool that you would need throughout expansion and additional lines and things like that?
So I ask this question to a lot of companies. And I ask, in 20 years, when that new crop of college students come out, where do they want to work? Are they going to work at that company that has a simulation model or no simulation model? And it gets them thinking, because there's a point there. You have to stay in advance of what the technology is present, right? You can't stay in the past, you go into the future. So when I ask that question, I ask it because that digital model isn't, you do it once and it's in the past. It's there because in the future, these new college students who come in, you have to train them up. Hey, look at the digital model. Do a dry run with in the virtual model in a simulated environment. It trains them up, it gives them information. But take it even further. You go into the design like, hey, I'm an engineer, I have a great idea, but no one's going to pay attention to you because it means downtime on a physical world. But in a virtual model, I go modify my virtual model, do a what if scenario, make my business proposition, and then go sell it to the manufacturing leads. And they say, you're right, this is a great idea. And it didn't cost the company any downtime. So this virtual commissioning with the plant simulation is not a tool for just today to forget. It's there for continually every year to use.
Interesting. Yeah, I think of virtual commissioning and simulation for sure as to prove out a layout, test out different what-if scenarios. But the point you made about training a workforce as well without having to use up that equipment time, bring the machines offline for training purposes, that's definitely a use case I didn't even think of. Okay, so of course, speed and scale are critical with these battery manufacturing plants, but they mean nothing unless you can get those really high yields. In a high speed, high volume manufacturing facility making batteries, what is a critical factor in maximizing production yields? Obviously, it's not just about quality. What are some of the factors?
Well, in essence, I think a key factor is MES solution. An MES solution will enable the battery facilities to really become operationally faster because of high volume and high speed, but also more reliable. If you produce a lot of batteries and they are low yield and low quality, what have you accomplished? You're not achieving the goal you want. You want that high yield. So allowing the MES to manage those processes and identifying trends in the production early on really helps you be high volume and high speed, because that quality is an after effect, right? You start getting defects, all right, but now you're managing the defects. That's not where you should focus on. You should focus on collecting and aggregating the real-time data, identifying a trend, maybe through a statistical process control chart, and then being able to say a trend is occurring and stop it before it even happens. So we think of quality, and one of the things that if you ever talk to a quality group, the cost of quality increases in time further along you find it. So the earlier you find it, the lower the cost. The later you find it, the higher cost. And if it leaves your facility as an escape, then there's brand reputation issues. And you don't want that. So what's important is that MES solution to really drive that you can continue to hit the high rates and high speed without introducing the quality issues.
And it's really the only way to keep up with the high speed of these automated lines is to have extremely advanced MES system that's capable of gathering data quickly, capable of sending that data in a usable format to all these different enterprise solutions and integrating together and being able to take action on that data.
So, we go back to the talent. The talent in the market is really new to battery manufacturing. And I have discussions with them that the line will do a kick out, automated quality control. It failed an inspection. So we kick out the cell from the line. And they ask me, can we inspect 100%? And I ask, are you sure you know what you're talking about? You're gonna have one battery a second. If you have even a small amount of defect, you may have 100 cells being kicked out an hour, and you wanna mitigate each one of those. So this goes back to, the system's going to be there to help you. Let it do it. Let it automate, collect the data, and then make decisions for you, instead of a more traditional approach, which is I have to be there and make the decisions for you. Let the MES system work for you. And that's a key characteristic of why the US market is going to be more competitive than the international market. Because the international market still has that mindset. And here in the US, our mindset is innovation, creativity. And when we do that and we couple it with technology, we will be the best. And that's important to realize. And that's a really important factor in overall success in battery manufacturing. So another key factor is traceability. Right? We're high volume here. You can no longer do it through a manual process to track everything that happened on the manufacturing floor. You need that MES system for the traceability standpoint, for where, who, what, when these things happen. And you want a complete digital record to track and trace everything that happened. And that's what the MES is for. It's going to digitally record everything that happened. So if any event that qualifies as an issue occurs, you can start doing containment based on a set of criteria. That cell went through that equipment, which was identified to be faulty because the cutting mechanism was worn out for 15 minutes. That's all it was. You can then do a containment with the traceability data in the MES and block that from ever leaving the facility. So that's really one of the other major powerful factors of the MES. Let it do the hard work for you, and let you, as a user, focus on what you need to do to make the line run as fast as possible.
So this traceability data lets you see exactly what happened throughout the life cycle of the battery. I'm assuming there's a ton of regulations and potential audits that might take place. Katerina, do you know, can you tell us a little bit about some of those regulations that a battery manufacturer has to navigate, that having more visibility into the traceability and the life cycle of the battery will help them stay in compliance with?
Well, yes, one of the most, prominent regulation that everybody heard of is battery passport in European Union, and I think it's coming into effect very soon. And basically, in order to sell battery cell into European market, you have to provide a battery passport that captures all the data on how battery was manufactured, what is the CO2 footprint of this battery cell, where the materials come from, what is the amount of recycled materials in this battery cell. And really, it's only possible to trace and track all this data if you have robust systems like MES into your factory.
All right, let's talk more about greenfield facilities, brand new, starting from scratch, where everything is built from the ground up, tons of uncertainty. For these greenfield facilities, where unknowns like equipment, processes, nothing is defined, how can Siemens technology help?
So in greenfield projects, battery manufacturing is filled with a lot of unknowns there because the workforce hasn't done this before, or they're bringing knowledge from different processes and bringing it together. So when we think about a greenfield, we have to think about, well, what are some of the key elements? It's the routings, the bill of materials, but even those become unknowns because the chemistries are unique, the production processes are unique, and these businesses come together and they have to solve those problems. So leveraging something like a simulation model that we talked about that simulates an entire manufacturing floor is really important because now we can start talking a common language. When we say, what is cutting and stacking? We can go to that virtual model and show that cutting and stacking process. Okay, what materials are being consumed in that location? The model will show you that. And that simulation tool really helps these greenfield sites because now we're talking and seeing the same thing. Where if without it, it's a game of telephone sometimes. I say A, you say B, you say C. How do we get to C? And it's unclear. So Siemens does provide these advanced simulation tools that manufacturers can then use to model everything from the facility processes to the way the materials move, to the way the AGVs are moving on the shop floor. By simulating the entire production line, material handling, machines, and everything, you really get to see what's happening. And you'll be able to see identification of bottlenecks in your logistics, bottlenecks in the material consumptions, run rates, potential defect areas, and it really brings everyone together because now that data is the same. Now the best part of it is because it's part of the simulation model, part of the portfolio of Siemens, it's connected. So that feeds into the MES, that feeds into the PLM system, and PLM can feed into the models. And that really helps drive innovation before the site actually gets built. And that is really, really important because early on, you have a bunch of experts in the room, very smart guys and ladies. They're very, very, very smart, and they know their processes very well. But when it comes to gluing that all together to run a manufacturing site, you really need to leverage the tool set to make that happen.
Yeah, and I want to mention something that I learned this year. I was at a construction of mega facilities conference, and I learned a lot of things about concrete. So concrete floors in a gigafactory can fail. And when you're building gigafactories, you can use different techniques to make certain areas are more robust and some areas, and it costs more. And when you have the model of your plant and you know how machines are moving and which areas get more stress in the future, it also affects your decisions about what concrete to pour into your gigafactories, right? Yes. So it's important because you don't want to fix your floors every couple of months later on. That's downtime right there.
There's a lot of factors, and talking about more of the physical elements of the factory build, some of the factories have multiple levels of floors, others are flat layered. They both come with their pros and cons because of the people movement, visibility of materials. Again, the simulation model will make that very clear. And you may realize something very quickly. I'll give an example. If you have multiple floors and you talk about human beings, they're going to have to go up the stairs or take an elevator. That's time. That's money. And if you can eliminate that and they're making minimal amount of movement while focusing on productive activities that are supporting the overall process, you're being more cost effective, reducing your overall cost of ownership. And not cost of ownership, but return on investment.
So for these greenfield facilities, obviously a huge factor is you've got to make decisions very quickly and you need to prioritize what's the most important thing to focus on day one, so that we can use our limited resources and time to get to market as quickly as possible. We know the Siemens solution stack has a large number of offerings, which is amazing. Once you're fully up and running, what are the best ways to kind of get started as you're building this greenfield facility to make sure you're taking full advantage of these digital tools and technologies?
I'm not sure there's going to be a right way or a wrong way on those first steps. I always will say, start with your routings, start with the BOMs, the master data, because everyone surrounds there, and it supports both manufacturing, engineering, finance teams. Well, after you get past that, then you really need to start understanding your physical world. And that's difficult for a greenfield without the physical world in front of you. It's easy to go show me and point. This is how our process works. Now explain it to me with nothing in front of you. And that's where probably my intuition tells me you need to get a model in place. Start with a good model, and that model will grow into everything else, because it's going to feed decisions, it's going to feed the systems, and help that greenfield site ramp up faster.
And in some cases, if you have a robust model, it helps you to raise capital for your factory, because investors want to understand how much labor will be needed for this site, how much capital expenses you have to invest. So modeling is important for many areas.
Yeah, modeling is very important, and I'll kind of talk about it in a life cycle of a product. The first part is the design. So if you use a PLM to design the materials and then use that to also define your manufacturing processes, you already got your first iteration version controlled. And as your business iterates and understands better, you'll revise that and you have the history. And if you ever need to go back, you can. And that same data, because it's connected to the shop floor, gets pushed down to the shop floor for execution. So now you don't have to do all this manual work of copy paste. It's just download, and now it's there in your manufacturing execution system, and then you start executing runs. And that's where, okay, I just realized I have a key data point that I want to collect. This CCD information was missing. I'm going to make a request back to the master data. Hey, I want to include this CCD for collection, and it will push that change workflow and drive it right back to the shop floor. And then everyone's connected. So a design engineer can look at it too and say, that's really smart. Maybe I need to go change it in some of the other process areas as well. So it really drives innovation when we have this connected platform, because everyone has the same data, the same model, and they're interacting in different viewpoints as a designer, as a manufacturer, as a quality engineer.
Wow, that's a lot of things to consider. I know in my experience, there's really no cookie cutter answer. Every customer goes through a different journey based on their technology, their processes, their equipment, their workforce. So I'm guessing probably pretty important to have partners like Siemens and Index working alongside you. If I was starting a battery manufacturing plant, I would probably want the two of you guiding me. So yeah, definitely great information. Thanks for that. Okay, so whether we're talking about greenfield or brownfield, new or old plants, experience is everything. Let's talk a little bit about how that plays into Siemens and Index's approach. Can you explain how you approach new greenfield and brownfield battery plants based on, let's say, Index's experience supporting battery production projects?
So at Index, our approach is to support both greenfields and brownfield battery production plants. And it's built on a deep understanding of the unique challenges they face and the opportunities these projects present. So drawing from our experience in battery production projects, the challenges that we saw and continue to see, we know that success lies in leveraging the right technology, strategic planning, and proactive risk management. Identifying those risks upfront is very critical. One of the key risks that I always call out immediately is, how am I going to integrate to the equipment? This is high speed, high volume production. My main value statement here is integrate to the equipment. So at Index, we really know what to look for and how to guide a manufacturer through these processes to be able to accomplish a ramp up smoothly and smartly. Our knowledge in the battery manufacturing landscape is really important because we need to understand the pain that manufacturing has, the pain that designers have, the pain that quality engineers have. I mentioned before the kickouts. Like, I know that story, and I know when a quality engineer will ask me, I'll challenge. And that's what we get from the experience with Index. So Index knows how to ask the right questions, guide the business in making the right decisions to drive the innovation they need, adopt the technology, and help your people also start using the system. I think the people, the tools, and the process are very critical to work together for success.
So finding somebody who doesn't just talk the talk, but walks the walk, has a lot of experience, because that's really the only way to come across these actual challenges. Is I saw them in the last project I worked on, or 5 years ago when I was working with my client to get their 5th greenfield plant up and running in the last 15 years. This is exactly what happened. So I've seen this. So working on past experiences, past challenges, potentially past failures to help understand what to expect and proactively guide your clients basically to make the right decisions.
Absolutely, Drew. That's correct. That experience is a critical factor to our overall success, and being able to help manufacturers start up a greenfield or revise in a brownfield. Index hands-on experience with greenfield and brownfield battery plants allows us to guide projects with confidence, ensuring that both types of facilities operate faster and more reliably. Our knowledge in battery manufacturing landscape, coupled with the expertise in the latest technology solutions, help us address key challenges, optimize processes, and achieve successful outcomes. Whether building that from the ground up or modernizing existing systems, we know what works, and we apply that knowledge every step of the way.
Let's touch a little bit on the complexity of working across continents and collaborating across the world, especially with those Asia-Pacific based line builders, let's say. How can those gaps be bridged effectively? What are some of the challenges when working with Asia-based line builders for US-based battery facilities? And how does Siemens Digital MES framework help bridge those gaps?
When working with APAC line builders for US-based facilities, there are several challenges that can arise. That includes differences in manufacturing practices, communication barriers, time zone issues, and the complexity of managing a cross-border supply chain. Working with teams in different regions often leads to communication challenges, especially when it comes to aligning on technical specifications, timelines, and production requirements. Differences in the work culture is also impactful because of what I say, because I use paradigms that are like baseball terms may not apply well to them. So you have to be very careful and very good about how you communicate. Another item is a significant time zone difference between the US and APAC can really slow things down. Decision-making, problem-solving, and coordination efforts. Think about it, I have to wait 24 hours, or the only time we can meet is in my evening and in their morning. So it becomes very difficult to coordinate all of that. And that real-time collaboration can be very difficult. It leads to inefficiencies, and issues arise because of it, because of the slowness of the decision-making process. As a central foundation, talking to the Siemens MES, kind of standardizing on that model that I mentioned earlier, helps everyone talk the same. Because now I got a systematic way of communicating things based on specs that line builders can follow in a uniform way, regardless of the geographical location. Everyone's going to talk the same. This reduces the chances of discrepancies in the machine setup, operations, quality, and it helps align the two regions. Really, I would say what I found successful with these APAC line builders is instead of relying on just verbalization of what you need or written formats, being able to model it within the system and then showing it in the system really made a big difference. Because now when we talk, everyone will remember that image of the system and how it interacted, and then we talk to that. And that's really, really helpful when we do these cross-regional line builds.
So you're saying technology is kind of like the universal language. Once everyone sees exactly what you're doing, those language barriers and other cultural differences and barriers are broken down a little bit more.
Yes, absolutely.
Another big challenge is the disconnect between how lines are designed in Asia or how they need to operate in the United States. Different standards, different compliance requirements, and often different levels of automation. You can run into issues with language barriers, as David already mentioned, documentation gaps, and if you have only minimal digital connectivity. And this is where Siemens digital MES framework centered around Ops Center execution makes a huge difference. Ops Center helps standardize and digitize your manufacturing operations, no matter where the line comes from. It acts as a glue between imported equipment and US operations by providing a centralized process control, real-time production visibility, standardized work instruction and traceability. And even if your line builder didn't provide strong digital integration, you can connect that equipment through industrial age or manufacturing operation management interfaces and bring it under one digital umbrella. Plus, with Team Center and Easy Plan, you can align design, process, and execution, even across global teams. That helps close the loop between imported hardware and local production needs. So in short, Siemens MES framework bridges the gaps by making global hardware and local operations work together seamlessly and digitally.
So no stranger to working across countries and regions and across the world. It seems like we've got a lot of tools in our belt to navigate those challenges. Very cool. Okay, so one of the most powerful tools available to manufacturers today is plant simulation. We've talked about this a little bit today, but how can virtual plant modeling and simulation tools like Siemens Plant Sim help manufacturers validate their throughput and optimize their production lines before a facility even comes online?
Think about it. We have a virtual plant model, and we have emulation tools like Siemens Plant Sim. That's invaluable, right? It allows the manufacturers to see the manufacturing processes and validate throughput and optimize that production line before the facility even goes live. These tools create a digital replication of the material movements, the logistics, the quality issues, the line performance. And it can simulate the entire process so you can identify bottlenecks. All are risk-free because you don't have to impact the actual production line, and it's all in a virtual environment.
And getting a battery facility up and running is not easy, as we all know. You have tight timelines, complex equipment, and zero room for error. That's where digital tools really start to shine. Plant simulation, for example, think of it like building a digital version of your entire facility before you touch a single piece of equipment. You can lay out your workstation, conveyors, AGVs, even simulate flow of people move around, and then run it all virtually. You can test different demand scenarios, spot bottlenecks, tweak layouts, and see what happens if supplier is late or if machine goes out. Basically, it will let you to debug your factory before it even exists.
So it sounds like this will help me make very tactical, everyday decisions, as well as the very high-level strategic, executive-level decisions that help me, guide the direction of my company, of my construction. I guess which areas of the business are most affected by the data that we're gathering from these simulation models? Like who is able to gather data and make those decisions?
Manufacturing is going to impact manufacturing the most because think about it. I'm a manufacturing engineer. I have no simulation tools. How am I going to validate something? I have to go do something on the manufacturing floor, potentially do a temp order to produce a temporary product to prove out something. So I'm impacting production. But with a simulation tool, I'm doing that within my simulation. Okay, let me change this and see what my impact is in my throughput or maybe my quality based on the simulation model and historical evidence. So I see manufacturers, not only the MEs, but then let's take it a little lot higher up. Let's say I have to do a capital investment plan. I mentioned the gens of lines. So now I'm on my Gen 2 line and someone says, hey, some new technology in the market became available and we can increase the yield by 10%. Well, management's going to want a use case and supporting evidence to show that the investment they're going to make will have a return. So you create the simulation model and make the slight adjustments based on new technology, and now you have your ROI that you can go present. So it can also be used in the executive decisions for capital investments to improve your overall market dominance.
So we see clients using this information at the very highest management level to build business cases and ROIs and actually use it to make business decisions?
Absolutely. They're using that to make the decisions based on a simulation model because it has zero impact on the manufacturer. And that's critical. Otherwise, how do you have that data? You'll have to do maybe longer studies. You're going to cause some disruptions on the shop floor. Try or just, it's not easy, right? So you need that simulation tool to really help CIOs, CEOs make good decisions.
So without that, you're kind of relying on tribal knowledge and just guess and check and using up critical equipment time for trials, things like that. All right, sounds like a very important tool to have. So wow, yeah, that's obviously a great example of getting ahead of the curve using a technology like PlantSim. How does early simulation of the manufacturing environment contribute, let's say, to better MES configuration and ultimately, a faster ramp up to getting to high volume production?
So the simulation model early on has helped to make decisions on how to design the process. But then you take that simulation model and you can use it to execute something called virtual commissioning. So virtual commissioning is using that simulation model to replicate what the manufacturing floor is doing and feeding the MES system with all that information. So now you can do a commissioning of your MES without having to wait for the actual equipment to ship, which, by the way, has very long lead times. You may not see that equipment until months before your start of production, which gives you a very narrow window. So being able to accelerate that very early in the project, now you can do digital commissioning with the simulation and MES, validate your MES system with, okay, the integration points, okay, is there any kind of potential load that we need to resolve? Because we're talking about high volume, so a battery a second could cause potential bottlenecks. Being able to identify that all through this virtual commissioning process with the virtual model is very critical for a greenfield that's starting up. You're going to reduce your overall risk on the project. And that's very, very important. I mentioned before, one of the top risks I always find is the integration to the shop floor. Who's orchestrating that integration? Is it commonized? Am I going to have to address multiple vendors' APIs? That virtual commissioning helps get past all of that. Because now I have an exact model, I figure that out. If I get 6 months earlier than when the actual equipment lands, that's 6 months of opportunity to optimize.
So you're saying this PlantSim model is not just a kind of a theoretical tool for testing out layouts and bottleneck analysis. It can actually be connected to the logic of the PLCs and integrated to these technologies to make actual decisions based on real data?
Absolutely, and there's various levels of commissioning. Virtual commissioning based on the entire line, but you can get down to the PLC level too. You can simulate the robotics and the PLC programming and then validate your programming of your robot before you actually have a physical robot. Again, saving you time. Otherwise, how do you do that? Yeah, I've seen this all the time. That engineers with their laptop sitting next to the robot, programming it away, verifying it, and you have to lock the resource in. So again, another wonderful benefit of virtual commissioning.
I'm assuming Process Simulate from Siemens technology also comes into play there when you brought up robots and integrating with automation equipment. Is that another tool that we see is super important for validating using that virtual commissioning?
Yes, absolutely. It's a tool set. Each of those tools have their use cases, but combined with Process Simulate and Plant Simulate, the Technomatic suite, you'll be able to do that virtual commissioning in its entirety. Virtual plant models help simulate the integration of various production systems, including machinery, automation, and control software. This allows manufacturers to test how different systems work together, identify potential integration issues, and make adjustments before the physical commissioning begins. This reduces the risk of delays during the actual commissioning phase.
Such an important point. Absolutely. Early simulation doesn't just improve MES setup. It really helps create that foundation for smarter decision making across the entire facility. So speaking of smart decisions, let's close today's conversation with one of the most transformative technologies that we see in play today, artificial intelligence, AI. What is Siemens doing around AI that is going to transform battery design and manufacturing?
Of course, no interview without question about AI. But yes, Siemens is really leaning into AI to help battery manufacturers to move faster, make smarter decisions, and optimize at every level, from cell design to gigafactory operations. On the design side, we are integrating AI into tools like SimCenter and NX to automate optimization. For example, AI can analyze huge simulation data sets to recommend the best cell geometry, cooling strategies for EV packs, or material configurations. That means faster iterations and better performing batteries with less guesswork. In manufacturing, we are embedding AI into op center execution and op center quality to drive real-time decision making. Think AI-powered defect detection, predictive maintenance, and quality analytics that learn from your data and flag issues before they become downtime. And with Industrial Edge and Insight Hub, Siemens is enabling AI right at the machine level, helping to identify patterns in energy use, line performance, and even operator efficiency. That's critical, scaling sustainably and reducing waste. What's exciting is how this all ties together through accelerator platform. So whether you are building a new battery product or running a gigafactory, Siemens AI is helping you design smarter, produce faster, and continuously improve using real actionable insight. So it's not just a hype. AI is already being built into the core of the battery solutions that Siemens provides to battery industry. And it's already transforming how this industry innovates and scales. And as David earlier said, the United States has a lot of potential for innovation, and this is how we will become competitive in this industry.
So we're not just talking a chat bot, basic AI functions here. We're talking actually using AI to drive design, to make high-level decisions, to connect to our manufacturing systems. So really very advanced technology, not just surface level AI just to say we did AI. It's really integrated within that full accelerator portfolio.
Yeah, it's really exciting, and it's just the beginning.
Wow, yeah, very exciting. All right, thanks so much to everyone for joining us today, and a big thank you to our panelists from Engineering Industries Excellence and Siemens for sharing such valuable insights. It's clear that the battery industry is facing massive opportunities, but also significant complexity. What we've heard today is that digitalization is not just a competitive advantage, it's becoming the foundation for long-term success in this space. So whether you're launching a new facility, scaling operations, or preparing for the future, well thought out strategies and technology partnerships make all the difference. So we hope today's discussion gave you a much clearer picture of what's possible. Thanks again for tuning in. We look forward to continuing the conversation. Thank you so much.